Welcome to this masterclass explainer on GitHub Copilot's advanced capabilities. Look, if you're just using Copilot as a glorified autocomplete, you're barely scratching the surface of what it can actually do. Today, we're moving way beyond basic code completion to unlock true autonomous engineering. We're going to dive into the exact workflows professional teams are using right now to scale their productivity and enforce architectural standards.
Here is our game plan. We've got 5 sections covering a complete professional arc. 1. The power of agent mode. 2. Advanced developer workflows. 3. Global custom instructions. 4. The Copilot Extensions ecosystem. And finally, 5. AI limitations and guardrails.
All right, let's kick things off with Section 1, the power of agent mode. So this capability is currently available exclusively in VS Code and GitHub Codespaces. And the absolute most crucial concept here is that word autonomously. Unlike standard chat, where you ask a question and it just gives you an answer, an agent is proactive. It autonomously navigates your project's file folders, reading what it needs, writing code across multiple files, and, get this, it even runs terminal commands to verify its own work. If you have a complex refactoring job or you need to set up a massive project scaffold from scratch, agent mode iteratively executes a series of multi-step actions to just get it done.
To really grasp this paradigm shift, think of it like this. Chat mode is essentially a highly intelligent consultant. It gives you passive advice in a single response, maybe suggests some changes, but it can't actually touch your terminal. Agent mode, on the other hand, is like an active pair programmer. It's actively and iteratively changing your codebase based on its own findings. It can literally run a test, see that the test failed, read the terminal output, and then jump back in to fix the code to make it pass, all in a continuous multi-step loop.
That brings us right into Section 2, Advanced Developer Workflows.
Let's talk about how this impacts daily productivity, starting with test-driven development, or TDD. We all know developers often avoid TDD because writing the boilerplate tests just takes way too long. Well, Copilot acts as a massive accelerator here. It's a simple 3-step dance. Step 1, you just write a descriptive comment or docstring laying out your requirement. Step 2, Copilot scaffolds the exact unit test for you, anticipating the edge cases. And step 3, you use that test as a strict specification, and Copilot implements the actual code to make the test pass. You drive the architecture, and the AI does the heavy typing.
Beyond TDD, you really need to master your daily workflow using slash commands and context variables. Just place your cursor inside a function, type /doc, and Copilot will instantly generate beautifully formatted doc strings tailored to your language, whether that's JSDoc, JavaDoc, or Python's Google style. Got a bug? Highlight the code and use /fix. But okay, my absolute favorite trick is rubber duck debugging using the @terminal context variable. If your build fails, stop copy-pasting the error. Just ask Copilot chat, @terminal, why did my build just crash? And let the AI analyze your exact runtime errors directly from your local environment. It's brilliant.
So how do we scale this across a team? Welcome to Section 3, Global Custom Instructions. It's awesome when one developer is fast, sure. But what happens when you have 50 developers all using AI and they're all generating code in slightly different styles? You solve this by creating a specific markdown file right in your repository, .github/copilot-instructions.md. This single file is how you enforce your engineering team's unique coding conventions globally.
This setup gives your senior engineers an incredible level of control. This markdown file, which is currently capped at 8 kilobytes, just sits in your repo. Every single time a developer in that repo interacts with Copilot chat, the contents of this file are silently prepended to their prompt as context. This ensures that the AI suggestions strictly follow your custom architectural rules. You can define exact error handling patterns, enforce specific naming conventions, or tell the AI, hey, always use this specific internal framework for data fetching. You're literally turning a generic AI into your team's own custom AI.
Moving right along to Section 4, the Copilot Extensions ecosystem. Beyond your custom code, we can actually expand Copilot's brain to understand external tools. By integrating third-party Copilot extensions from the GitHub marketplace, your chat interface gains deep domain knowledge about your infrastructure. Suddenly, you can type @Docker to get expert help debugging containers and compose files, or use @Sentry to ask Copilot about a massive spike in production errors happening right now. You can even query your Datadog observability metrics using plain English. You're pulling complex external operational data right into your IDE, so you never have to break your flow by switching tabs to figure out what's going wrong in production.
Okay, let's dive into our final segment, Section 5, AI Limitations and Guardrails. Look, a true masterclass doesn't just teach you how to use a tool, it teaches you exactly when not to use it. We have to be real about how the machine actually works. Copilot is constrained by limited context windows. If you have a massive, sprawling, monolithic file, the AI simply might not be able to read the whole thing at once, which leads to it missing crucial dependencies. Furthermore, large language models produce non-deterministic outputs. Because they're probabilistic by nature, the exact same prompt you type today might generate a completely different code snippet tomorrow. You cannot treat AI output as guaranteed repeatable math. Consider these your hard stop signs. Never rely on AI generation for novel algorithm design. It's great for boilerplate, but it's not for inventing complex, unproven mathematical logic. Custom crypto? Almost always a bad idea anyway, but the AI might suggest weak implementations because it saw them in older public training data. Do not let AI write critical, authentication, and authorization logic without expert human review. The same goes for highly regulated compliance code, like HIPAA or PCI DSS. And finally, never accept a suggestion that includes hard-coded secrets, API keys, or passwords. The AI might hallucinate a dummy password, or worse, suggest one it has seen before in the wild. Ultimately, it comes down to the core philosophy of responsible AI use. Copilot suggestions are just that. They're suggestions. They're starting points, not finished audited code. When you press tab and commit that code into your repository, your name is on the Git blame. You are responsible for the code you commit. Not the AI, not GitHub, and not Microsoft. You cannot use Copilot wrote it as an excuse for a security vulnerability during a code review. As we wrap up this explainer, I want to leave you with this one vital question. We started by looking at the incredible power of agent mode, taking multi-step actions autonomously across your codebase. It really is an amazing capability. But when the agent acts autonomously, you must still maintain the human oversight to truly understand and own your application. If a junior developer on your team uses AI to write a massive caching layer, that's great for speed, but can they actually explain how it works when the system goes down at 2 a.m.? Use the tools, accelerate your workflows, and set up your team instructions. But ask yourself, if the AI writes it autonomously, do you still truly understand the code you ship?